and also the idea of the essential nature of a state within a system, right? So here's the question. Given the following information of resources, determine which states are essential and which are inessential. So the first thing that you have to do is ask yourself, is state essential, which we're going to represent by E, is state inessential, which we're going to represent by I, right? Ask yourself if the state is essential or the state is inessential. So that's the first thing. Note, the total maximum resources is 300. So we know that the total distribution, DIS, equals 300. Okay? Next thing is, what we have to do now is determine whether the system is resource and system stable. So there's a lot of things that we have to do on this, right? The question is system both resource and system stable, right? Is system only system? Remember, you can't have just resource stable, you can't have that. Or is system, so there's a lot of stuff. Now all I'm going to do is give you a series of numbers, right? And these series of numbers correspond to the amount of states in the system. So I'm not going to solve all of them, and I do encourage you, try not to look at the footnotes, try and really solve these to make sense of it. So here's the criteria for answering the question, and here's what I give you. I give you the following, and I made, 1 through 5, I made the distribution of resources up myself, right? So imagine that we have 82, 73, 90, and 55. And let me get my calculator. So we have 82, 73, 90, and 55. First thing that we recognize is that we're going to be discussing resource and system stability within more than 3 state system, right? This is obviously representative of more than 3 state system, 82, 73, 90, and 55. We recognize that the total distribution is 300. So all of this first should add up to 300. So let's just do the math really quick. And this is out, even algebra. It's just like arithmetic. 82 plus 73 plus 90 plus 55 equals 300. Okay, so we're good. So it equals 300. Actually, I won't put it down. So now we ask ourselves, we start to think, okay, I need to ask myself if the states, or are the states, is each particular state essential or is it inessential, right? And the question was, remember what I just said, before this, how do we determine whether or not a state is essential? We determine whether or not a state is essential by going through those steps that I listed, right? What is the total amount? 300. What is half of that amount? 150. What is the state with the most power? This is the state with the most power, state C. So this is A, B, C, D. State C has the most power in this example by having 90. How far is state C from attaining half the total distribution? Well, it would be 60, right? So if you take 150 minus 90 equals, it's 60 points off, right? Now, you have to be able to transfer at least 60 points to state C in order to be essential. The question is, can A transfer 60 points? Yes, obviously, and have leftovers. Can B transfer 60 points? Yes, that would bring this to 150, that would bring this to 150. Can D transfer 60 points? Obviously no, it's more than it has. It can't transfer 60 points. So what we immediately recognize is that D is inessential. Right? D, in the example 82, 73, 90, and 55 is inessential. Right? So insofar as this is inessential, D faces elimination. right, D faces elimination. And what is more than likely going to happen, right, because D, it's not the case that it has to happen, right, but it's more than likely that it will happen. And if members of state C were wise, C would absorb all of D to get 55, right? C would absorb D to get 55, which would bring it to, I think, 145. 90 plus 55 is 145, which would still be below the amount. It would only need 5. Both of these would be essential because they both could transfer 5. So this is first wave, right? In second wave, we would have 82, 73, and 145, right? We would have A, B, and C. D would have been ejected from the system because it's inessential. Now, it doesn't have to be the case that that happens, but it's likely that it will happen. So what we would have ended up doing is gone from a 3-state system, right, in which we had potential instability and ejected a state from the system. And then we arrive at a 3-state system where all states are essential, right? All states are essential in this. But we also recognize that in this state of affairs now, to answer the rest of the question, right, that, well, obviously, there's going to be resource competition here, right? In this state of affairs, once we've gone from a 4-state system to a 3-state system, the question becomes, is it resource stable and system stable? Well, we know it's going to be system stable, right? So system stability, check. And the question is, why is it system stable? Because I can appropriate, both state A and B can appropriate the resources needed to challenge. Well, I mean, then again, it depends. It depends, right? It depends. It is system stable, but you can see what would end up happening. The combination of A and B could attack C, but there would still be a distribution. It is system stable, but there are counter arguments to that, right? So system stability, yes. Is it resource stable? No, right? It's not resource stable. Why? In order to preserve my stake in the system, I am mandated to transfer. Both B and A are mandated to transfer 5 units. The refusal to transfer 5 units will lead to system destabilization for whatever state that refuses. But no state would refuse, because to refuse is to deny your own existence in the system, right? You're necessarily eliminated from the system. I'm not trying to get into that point because that gets a little bit more complicated. So we recognize in this example that state D is not essential, it's inessential. We recognize that the transformation, if it happens to be the case, from a 4-state system into a 3-state system after D has been absorbed by C will result in system stability if and only if both A and B agree to transfer 5 units to state C. Then we would have a system only, this would be a representation of a system only, a 3-state system only stable system. If either A or B refuse to transfer 5 units, then it destabilizes the system, right? So this is system stable, but it's not resource stable. Why? Because the resources have to be transferred. So, yeah, that one was, and I do recognize the, sort of the amount of detail that went into that analysis. I commend Midlarski for the publication. I mean, this is a really phenomenal resource for educating. And Moreau really went deep in his analysis. There's tons of stuff in Moreau's article that I also could not extend. But I'm, I think, 7 or 8 hours into the lecture now, 2 hours of which have been spent on Moreau's chapter. So, that's all the time that I have for that. So, with that being said, I want to thank you for sticking around for all of these hours and watching my series on international war and terrorism. With that being said, I'm Dr. Jason J. Campbell. Thank you and have a good day.